Hello Maths fans, and I'm back again with some help with Maths Watch clip 184 I think it is, but this was part of an assignment homework, and on that it appears as question 1, and these are circle theorem proofs. Okay, so like proof with anything else, we must lay our working out step by step, which must lead to a valid conclusion. Okay, so looking at this one here, again, the reading of the question is very, very important here, okay? ABC are points on a circle such that BC bisects angle ABQ. Where's ABQ? ABQ is the whole of that angle, and ABC bisects that. BC bisects it, in other words, cuts it in half. Okay, so what does that mean? Well, already we've seen that that's x. That must mean that this is x as well, if you think about it. Okay, so I'll fill that in just as I'm going along. PBQ is a tangent to the circle, and CBQ equals x. CBQ equals x, right. Okay, so what have we got to prove? AC equals BC. AC equals BC. So that would make that an isosceles triangle. So if we've got to prove the two lengths are the same for an isosceles triangle, I'm thinking perhaps we've got to prove the two angles are the same. Okay, so really I've got an x here. I'm trying to show, I'm not saying this is true at the moment. I'm just going to mark this on here, but we're looking for AC is equal to BC. I'm just doing that there to remind myself in the diagram what I'm trying to prove. So really I'm hoping that's x there. Okay, circle theorem's got to help me out here. We've got tangent to a circle, tangents. 3 theorems involving tangents, aren't there? Angle between a tangent and a radius is 90 degrees. Well, we haven't got a radius. We could draw one in, but I don't want to do that unless I really have to. Okay, so that doesn't look like that's going to be working. Tangents from an external point to a circle are equal in length. Well, I've got one tangent. Yeah, and there's not 2 tangents from Q and not 2 tangents from P, so that's not going to be involved here. So the third one, the angle between a tangent and a chord, here's my chord, is equal to the angle in the alternate segment. It's the alternate segment theorem. Okay, now if you watch my previous videos on this, talking about the alternate segment theorem, let's quickly recap here. There's a chord that splits the circle into 2 segments, a minor and a major segment. So any angle between a tangent and a chord in this segment is equal to the angle in the alternate segment. So the angle that's equal to, if we call that y, so we're not confusing with this, it must appear in this segment over here, and it always bounces off the circumference. Okay, so I'm going to start from x and y. Let's start from x, bounce back to y. These two will be the same, alternate segment. And you might say, well, does that work always? Yeah, here, that angle will be the same. We could carry on doing this forever. And it backs up the theorem, the angles in the same segment are equal, sometimes called angles on the same arc equal. So, okay, how does this work here then? Angle between a tangent and a chord is equal to the angle in the alternate segment. So here's B and C, here's the chord. From B, bounce the circumference and back to C. That's the angle we're after. That must also be x. Right, I've got enough information now, I think. So let's start putting in, I haven't put anything down yet, have I? So let's go with that. Let's say CAB equals CBQ, angle CBQ, which is equal to x, must give my reason, alternate segment theorem. That's good enough for that. What else? I didn't write down this one, did I? ABC equals CBQ. And I'm just going to put given here because they said that angle bisected, didn't it? So that's equal to x as well. So what have we got? That must mean that triangle, therefore, remember there's 3 dots in a triangle, right triangle. Therefore, triangle ABC is isosceles. Therefore, AC equals BC. Okay, and let's say that we've shown that. Okay, that's it for that proof there. You can see a set of steps with reasons at each stage, leading to our final conclusion. Hope that makes sense, and I'll see you for the next one.